Hello everyone, welcome back to Diksha Karnataka YouTube channel, and in the KCET 2025 top 30 series I am going to discuss few important chapters from your PU1. For example, behavior of gases and kinetic theory of gases, thermodynamics, we have oscillations, we have waves. So all these chapters we are going to discuss in one of these simple video, and some of the questions will be from previous year questions. Some of them are very important questions. For example, this question is from previous year questions. This is little tricky. Let us understand the question. The PV diagram of a Carnot engine is shown in the graph below. The engine uses 1 mole of an ideal gas. So 1 mole of ideal gas means what is the value of mole number? So mole number I write using n. Some of you use mu. So whatever you are comfortable with, you can write it that. So n is 1 as working substance. From the graph, the area enclosed by the diagram is. So from this graph, you have to find the area enclosed by this graph. So area enclosed by this graph is basically the work done by the graph, right? So area enclosed is the work done by the system or work done by the Carnot engine. Okay, it is given that the heat supplied to the system is basically 8000 joules. So if we know that what is the efficiency of the Carnot engine, then we can find the work done is basically the heat supplied times the efficiency. So first of all, you have to find the efficiency. So what is the formula for efficiency? Formula for efficiency is 1 minus T of the low sink divided by T of the source. Okay, low temperature divided by high temperature. Always this is the case. Now you have to understand that the first stage is where adiabatic expansion is happening. So this is isothermal expansion. This temperature is constant. This is the temperature of hot source. Okay, so because at this temperature is high, the gas is expanding. Then adiabatic expansion, so temperature changes. So TAB is the constant temperature up to this stage. Then the temperature is changing and it is becoming from B to C, temperature is changing again. C to D, another adiabatic compression. So this is also a constant temperature, and then again the temperature changes, the final state, and coming back to temperature A. So this is how the entire thing is happening. This is a cyclic process. So this temperature TA and TCD, if we know that, we can find this. Okay, TCD is basically the low temperature and TAB is the T high temperature. This is the T high and this is the TL. Okay, so we will write the temperature TAB as T high and TCD as T low. This is little longer question, little tricky but solvable, and from your previous year question, so you cannot ignore this as well. So this is T high temperature and this is T low temperature. Now how can I find this temperature? Okay, P1 V1 is equal to P2 V2, or P1 V1 by R, T1 is equal to P2 V2 by T2. That formula is not useful here. So what we will be using, that this is an adiabatic process, so PV must be equals to constant. Okay, and also PV equals to nRT, right? So PA VA must be nRTA, right? TA or TH, whatever you say, right? So that is the formula we are going to use to find the temperature TH at the first stage. So TH equals to PA VA by R. Why R? Because n mole number is 1, so that is what we are going to use. Similarly, we can say that TL is at the point C. It is constant from C to D. So TL is basically PC VC by R. Right? Now what is TL by TH? So TL by TH is important because this is the formula for efficiency. So TL by TH is equals to PC VC by PA VA. Okay. Now what is PC VC? PC is 400 kilopascal and VC is 6.25 EM meter cube. Okay, now the constant does not matter because it's a division, it will be cancelled anyway. So 400 into 6.25 divided by PA is 1600 into VA is 2.5. Okay, so this is the value that we are interested in. So 1 by 4, so 4 into 2.5 is 10, so 6.25 divided by 10 is 0.625. So this is the value of TL by TH. So what is the efficiency now? So efficiency is basically 1 minus 0.625. So efficiency is 1 minus 0.625, that is 0.275. So this is the efficiency of the system. Now what is the work done? So work done is basically efficiency 0.275 into the heat input, that is 8000. Okay, so 8000.275 is 275 into 8, which will be equals to there is a small mistake, that is 1 minus 625 is 375. Okay, so 375. Now 370.375 into 8000 will be 375 into 8, right? 1 2 3 decimals, 1 2 3 zeros, they cancel each other. Now how can we find it? Let's see. 5 4s are 40, we have 0 and 4 in hand. 7 8s are 56. 56 plus 6 is 0, we have 6 now, and 8 3s are 24, so it will be 30. So 3000 joules is the area enclosed by the graph. 3000 joules is the work done by the system. So if the work done by the system is 3000 joule, that will be the area enclosed by the system. So answer is 3000 joules. Now if you are preparing for KCET exam or Comet K exam, then you should definitely know that we have launched Abhyas KCET test series, where we are going to give you 35 complete tests. Okay, here we have part tests as well as full syllabus test, and if you are not yet purchased yet, go and purchase it right now. It is available for 1498. Briefly, it was available under a scheme because your PU2 results were out, that KCET 500. You can check if the coupon code is working or not. I was told that it should be stopped, but some students said that it is still working. So KCET 500, if the link coupon code is still working, then you can get it at a flat 500 rupees discount. And Comet K crash course is launched at a price of 1999. It is obviously a full-fledged crash course along with synopsis, chapter by synopsis, all the important concepts, and included full 12 mock tests. 4 of them will be part tests and 8 full length tests. As full test means it includes PCM, all 3 subjects. So if you are interested, please go and book your spot right now today. Now let's see the next question. A thermodynamic system undergoes a cyclic process ABC as shown in the diagram. The work done by the system per cycle is. So what is the work done? Now in the previous case, they asked you to find the area under the graph, and the graph looked difficult to find, right? So that's why it was really tricky to find. In this case, they asked you to find the work done, and that is the same question, but only thing is area under the graph is easy to calculate in this case. So area under the graph is the work done. So what is the area under the graph? Work done is equal to half base into height. Base is 10 minus 5, that is 5. Okay, base is 5. Now check the units. It is in meter cube, so no problem. Okay, and into height. Height is 400 minus 100, that is 300. Okay, so it will be 150 into 3, that is 450. So work done is 450. The area under the graph is 450 joules. Sorry, 5 into 15 is 750. 5 into 15 is 750 So 750, and if you see that as the pressure is changing, volume is constant, pressure is decreasing, and as in this case it is a reverse process. Okay, generally positive case is from where it is graph is like this way is positive if it is coming like this, but it is in the opposite anti-clockwise direction, so it is a work done is negative. So correct answer is minus 750 joules. So direction of the arrows are very, very important. Okay, if it is a clockwise process, it is going in the clockwise direction, then it will be positive. If it is going in the anti-clockwise direction, then the work done will be negative. Now next question. A Carnot engine takes 300 calories of heat from a source at 500 Kelvin and rejects 150 calories of heat at to the sink. The temperature of the sink is. So what is the formula? So heat accepted Q1 divided by heat rejected Q2 is equals to T of the hot divided by T of the cold. Okay, T high by T low. Okay, so they are directly proportional, so let's put the values. So 500 divided by 300 calories intake, right? 300 calories intake and 500 is the temperature. So 300 calorie intake and it rejects 150 calorie, and it the temperature is 500 and TL, so it will be 2. So TL equals to 500 by 2, that is 250 Kelvin. Okay, easy question. No conversion required. So centigrade to Kelvin, then Kelvin to centigrade. It is simple, easy question. Next, a Carnot engine working between 300 Kelvin and 400 Kelvin has 400 joules of useful work. The amount of heat energy supplied to the engine from the source is. So now this is very, very interesting. So it says that again we are going to use the same formula, but the formula is slightly different here. So Q1 by Q2 is equals to T high by T low. Okay, so T high is 300, T high is 400 and T low is 300. Okay, so we get that Q1 equals to 4 by 3 Q2. Okay, or Q2 is equals to 3 by 4 Q1. Now question, you still don't need to use the efficiency formula over here. The question is the useful work. Useful work means what? Useful work means the work done is basically given by the heat supplied minus the heat rejected. Okay, that is Q1 minus 3 by 4 Q1. So that is equals to 1 by 4 Q1, and that value is given over here is 800 joules, right? 800 joules of useful work. So that is the work done. So Q1 must be equals to 4 8s are 3200. Okay, so the answer is 3200 joules. Next is this question. This is also similar but slightly different. An ideal gas is taken via path ABCA as shown in the figure. The net work done in the cycle is. So here we are starting from this point, okay, and in going this way. So initially what is the net work done? So sign is not important over here. So as you see, what is the change in temperature? Work done is basically half height is 4 minus 1, that is 3p1 into change in volume, that is 3v1 minus v1, that is 2v1. So the work done is 3p1 v1. So 3p1 v1 minus 3p1 v1 is the answer. Sign is important, again it is an anti-clockwise direction, so anti-clockwise direction means it will be minus 3p1 v1. Okay, now a monoatomic gas at pressure P having a volume V expands isothermally to a volume 2V and then adiabatically to a volume 16V. The final pressure of the gas is. So first it says that monoatomic gas at the pressure P and having a volume V expands isothermally. Isothermally means PV equals to constant to a volume 2V. So first stage is PV equals to P1 into 2V. Okay, this is the first stage. So from here we get that P1 equals to P by 2. Okay, now next stage it says that, and then adiabatically to a volume 16V. So adiabatically to a volume means P1 2V to the power gamma equals to P2 16V to the power gamma. Okay, so this is the main thing. So second stage was this. So first stage PV, it started with first stage PV, then it goes to this stage isothermally. Okay, now it started at this stage and it goes to the next stage adiabatically. So adiabatically means PV to the power gamma equals to constant, right? Now we will put this value over here, but before that we have to simplify it a little bit. So P2 equals to 2V by 16V to the power gamma P1. Okay, so V cancels, we get 1 by 8 to the power gamma. Now what is gamma? Value of gamma is given 5 by 3. Okay, so 1 by 8 to the power 5 by 3 into P1. P1 is P by 2. Now what is 1 by 8 to the power 1/3? 1 by 8 to the power 1/3 is half. Okay, so entire thing will become 1 by 2 to the power 5 P by 2. Okay, so 5 by 3 means to the power 5 over here, right? If you multiply 5 over here, then you get 5 over here as well. So what is the 2 to the power 5? 2 to the power 5 means 2 multiplied 5 times, right? So 2 to the 4, 4 4 the 16, 16 to the 32, 32 to the 64. So it will be P by 64. Okay, 2 to the power 6. So it will be P by 64. Correct answer is option D. Interesting question. Now let's move on. 100 gram of ice at 0 degrees Celsius is mixed with 100 gram of water at 100 degrees Celsius. Final temperature of the mixture is, okay, take LF equals to 10 to the power of 36 into 10 to the power of 5 joule per kg. This is the latent heat of fusion. Then we have specific heat of water is given 4.2 into 10 to the power of 3. So what is the question is about? We have a 100 degree Celsius water. It is not boiling, it is only 100 degrees Celsius of water, and in between you have added 100 grams of ice, okay, at 0 degrees Celsius. Okay, so first what will happen, this ice will melt. So this ice will melt and it will consume some heat energy. What is that heat energy? The ice will consume a heat energy equals to M into LF. Okay, so M is 100 grams. 100 grams means 100 into 10 to the power of minus 3 kilograms. Because everything is given in kilograms, you have to convert it into kilograms. And LF is given 3.36 into 10 to the power of 5. Okay, so it will be 3.36 into 10 to the power of 1, 2, 3, 4, 5, 7. 7 minus 3, 4. So this much heat is only absorbed during the melting process only. So melting is done. Now everything is water. Okay. Now the water of that 100 gram. Now suppose it reaches to a intermediate temperature T. Okay, it reaches to a intermediate temperature T, and the water which is already present at 100 degrees Celsius, it also will reach the same temperature T. So how much heat absorbed by the ice to reach this temperature? The heat absorbed by the ice to reach that temperature is Ms delta T. So M is 100 grams, so 100 into 10 to the power of minus 3. S is given by this 4.2 into 10 to the power of 3. Delta T. Delta T means final temperature minus initial temperature for temperature loss, and temperature gain will be, and this is the heat gained by the water. Okay, and this much heat is gained by the ice. So this plus, so this according to the law of calorimetry, this plus 3.36 36. Everything is this this part of this calculation is based on the ice, whatever ice has attaining. Okay, so this much heat is attained by the ice only, and that is equals to how much heat is supplied by the hot water. So hot water supplied 100 gram was its mass, so 100 into 10 to the power of minus 3 into latent heat 4.2 into 10 to the power of 3 into its final initial temperature was 100, final temperature is T. Because it is decreasing in temperature, it will be 100 minus T. Now if you see that we can cancel this 10 to the power of minus 3, 10 to the power of 3. So these are cancelled. So what we got? We got 100 into 4.2 into T. So that is 420 T. So this is a 420 question, plus 3.36 into 10 to the power of 4, and that should be equals to 100 into 4.2, that is 420 into 100, so 420 into 100, that is 00, minus 420 T, another 420 T. 100 minus. Okay, now we take this one on the other side, so we get 840 T. We get 840 T, that is equals to 42,000 minus, if we multiply this 10 to the power of 4 with this, we get 33600. Okay, so we get 336 minus 420, which is equals to, so see, calculations in this case you have to do it. Okay, I can say some tricks whenever it is involved. Other than that, if there is no trick, you have to do the calculation faster. There is no other option in this case. Okay, so this kind of calculations you have to do it. You have to practice calculations. Okay, many of you during COVID days not practice proper calculation, so that's why you are all weak in calculation. Okay, so 00 are there, so 00 are there, 336, 420, so it will be 4 over here, and we get 4 and 3 will be 4, so it will be 8400 cancels, 84 cancels. So the final temperature is 10 degrees Celsius. Okay, next question, which of the following curves represent the variation of coefficient of volume expansion of an ideal gas at constant pressure? Okay, constant pressure, here you can see that alpha V versus T. Now we know that alpha V is basically for a ideal gas is constant. Alpha V is basically equals to 1 by T, so this is the constant value, so it will not change with 1 by T, it's changing. So whatever is value of 1 by T, the same value is alpha T, so this is a constant value. Alpha T and alpha V is equal to 1 by T, so it will increase with 1 by T value. Okay, so as long as it is increasing, it will be a linear relation, right? So slope is 1, it is passing through origin. Okay, it will pass through origin, so this is the graph. So option B is correct for this question. Very careful. A pan filled with hot food cools from 94 degrees Celsius to 86 degrees Celsius in 2 minutes. When the room temperature is 20 degrees Celsius, how long it will cool from 74 to 66 degrees Celsius in time? Okay, so first of all, what is the change in temperature? Change in temperature is basically change in temperature is 94 and 86, which is equals to 8 degrees Celsius. So first case, the change in temperature is 8 degrees Celsius and the time taken is 2 minutes. Okay, so time taken is 2 minutes. Now we know that change in temperature, rate of change of temperature, rate of change of heat, okay, is basically proportional to the mean temperature of the system. What is the meaning of mean temperature? difference of the system, T minus T surrounding. Okay, so this is proportional to this. Now what is the meaning of mean temperature? Mean temperature is basically you add these two and then divide by 2, as simple as that. So mean temperature for first case is basically 86 plus 94 divided by 2. So it is 180, so it is 90 degree. Okay, so the dt 1 by dt 1 equals to say a constant k times 90 minus 20. Okay, what is dt1? dt1 is 8, time is 2 minutes, equals to k into 70, right? So k value is 8 divided by 2 into 70. Now this value is very, very important. The same k value will remain for the second stage as well. So what is the in the second stage? This is first stage. So second stage, the temperature change, this is everything is 1. In the second stage, the temperature is changing from 74 to 66. So this is also 8 degrees Celsius. Time we are trying to find. Okay, what is the mean temperature? Mean temperature is 74 plus 66 by 2. Okay, that is 80, 140, 140 by 2, that is 70. Okay, so T M2 is 70, same formula we will use. Okay, so dt1, dt2 is 8 divided by delta T2, we are trying to find this temperature, equals to k is 8 by 2 into 70. Into the difference in temperature. So 70 minus 20, that is 50. Okay, so 0 0 cancels. So what is the even TT will cancel. So you get delta T2 equals to 2 into 7 divided by 5. So it will be 14 divided by 5, that is equals to 2.8 minutes. So it will take 2.8 minutes. This is Newton's law of cooling. You have to practice such problems more and more. We have solved the similar question in Abhyas KCET test series as well. Now next question. 4 rods with different radii R and length L are used to connect 2 heat reservoirs at different temperatures. Which one will conduct most heat? Okay, material is same. So we know that heat conduction is basically proportional to more amount of heat will be conducted if the area is more. Okay, and heat conduction is inversely proportional to the length. Higher the length, less amount of heat will conducted, and higher the surface area, higher amount of heat will be conducted. So now let's see which one is what. So more the radius, higher is the area. So we have to find a combination where radius is high and length is small. So if you see this combination, radius is highest 2 centimeter and length is smallest. So this will be the combination where the heat will be conducted fastest. In anomalous expansion of water, at what temperature the density of water is maximum? So density of water is maximum exactly at 4 degrees Celsius. Okay. Now the ratio of molar specific heat of oxygen is, so oxygen is a diatomic gas. Okay, diatomic gas means what is the number of degrees of freedom? Number of degrees of freedom is basically 5, right? So this is the degrees of freedom F. Okay, so what is the value of gamma? Gamma is equals to 1 plus F by 2. 1 plus 2 by F. So the value of gamma is 1 plus 2 by F. Okay, so it is 1 plus 2 by 5, that is 1.4. Okay, so the answer is 1.4. 1.67 is for monoatomic, right? Triatomic, the number varies largely. So this is the answer for diatomic. a certain amount of heat energy is supplied to a monoatomic ideal gas which expands at constant pressure. What fraction of the heat energy is converted to work? Okay, so certain amount of heat energy is supplied to a monoatomic ideal gas, okay, which expands at constant pressure. So it is expanding in constant pressure. What fraction of the heat energy is converted into work? So work is basically P dV. Okay, so to solve this question we have to use the first law of thermodynamics, that is dW is equals to du plus the heat supplied dQ is equal to dW plus du, right? So this is the amount of heat supplied. The some part is utilized in internal energy and some part it's work done. Now what is dQ? dQ is n Cp dt, and what is du? du is n Cv dt, right? And dW we don't know. So what is dW then? dW is equals to n Cp minus Cv dt by into nothing. Okay, so this is the value of dW. Now you have to understand that because work energy heat is supplied at constant pressure, that's why there is Cp dt. Okay, Cv dt is by definition of internal energy. Now what fraction of the heat energy converted? So what fraction of heat energy converted means you have to find work done divided by the heat supplied. So this is the fraction that we are interested in. So n, that's why we have not yet substituted Cp minus Cv equals to R. So you might see, sir, R, I can see R. Wait, Muddy. So now it is n Cp dt, right? So n cancels, dt cancels, we get 1 minus Cv by Cp. What is this? We know that Cp by Cv is the ratio of specific heats. Okay, for a monoatomic gas, what is the relation? 1 plus 2 by F. So 1 plus 2 by 3, that is 5 by 3, that is the gamma. So basically what we are getting over here is equals to 1 minus 1 by gamma. So 1 by gamma means it will be 1 minus 3 by 5, that is 2 by 5. So 2 by 5% of the work is basically converted into fraction of the supplied energy is converted into work. So answer will be 2 by 5. Little tricky and really a little lengthy question. If you know the answer, you can answer it. Other than that, little tricky question. Now next is 1 mole of oxygen gas has heated at constant pressure starting at 27 degrees Celsius. How much energy must be added to the gas as to double its volume? Okay, so 1 mole of O2 gas has heated at constant pressure starting at 27 degrees Celsius. Okay, how much energy must be added to the gas as heat to double its volume? So initial volume was now you have to remember that the pressure is constant. Okay, so P1 V1 by T1 equals to P2 V2 by T2. So you have to understand that P1 is constant. So P1 is equals to P2, so they will cancel because it is said that constant pressure. So V1 by T1 is equal to V2 by T2. So you have final volume is double, okay, double its volume. That means V2 is equals to 2V1, right? So V1 by 27 degrees Celsius means 300 Kelvin equals to 2V2, that is 2V1 by T2. So what is T2? So T2 is basically 600 Kelvin. Okay, so final temperature is 600 Kelvin. Now how much energy you must supply? The energy that you must supply is N Cp dt. Okay, now n is 1 mole. What is Cp? Cp is basically Cp minus Cv. Cp minus Cv equals to R. Okay, if you divide everything by Cv, what you will get? Cp minus Cv minus 1 equals to R. No, let's divide it with Cp. So if you divide it by Cp, you get 1 minus Cv by Cp equals to R by Cp, or 1 minus 1 by gamma equals to R by Cp. Okay, so Cp equals to gamma times gamma minus 1 into R. Okay, so this is the formula you have to remember. So n is 1, Cp is gamma by gamma minus 1 times R. This is a diatomic gas. For diatomic gas, gamma is equals to 1.4, right? That is 14 by 10, that is 7 by 5. Okay, 7 by 5. So let's put that value. So 7 by 5 divided by 7 by 5 minus 1 into R, okay, times dt. dt is 600 minus 300, that is 300. Okay, so it will be 7 by 2, 7 by 2, right? 7 by 2 R into 300. So it will be 150, 700 plus 350, so 1050 R. So answer is 1050 R. This much amount of heat energy you must supply. Okay, little tricky question again, based on lot of concept, but that's why I say thermodynamics may be little tricky at times. You can skip the concept if you are not very well prepared for this. But there are some questions like this as well, so if you get this kind of questions, you should be ready for those kind of questions. Pressure of an ideal gas is increased by keeping the temperature constant. The kinetic energy of the molecules, so pressure of an ideal gas is increased. Okay, pressure you are changing, temperature is constant. So P1 V1 is equals to RT1. Okay, temperature is constant means kinetic energy will remain same, because kinetic energy is proportional to half kBT. Okay, so if you keep the temperature constant, kinetic energy will remain the same. Okay, now next is pressure of an ideal gas at a constant volume is proportional to. So pressure of an ideal gas at constant volume is proportional to average potential energy of the molecules, total energy of the gas, average kinetic energy of the molecule. So pressure of an ideal gas is basically proportional to average kinetic energy. Okay, we have seen that if you are keeping the volume constant, then pressure will depend on kinetic energy. Next question. For a particle executing SHM, simple harmonic motion at its mean position. So now we have moved from all the thermodynamical chapters to simple harmonic motion. Let's see. We have a bob over here. We have this is the maximum position, this is the minimum position. So what is the question? At the mean position, so at this position when the particle reaches over here, okay, so at this position its velocity is 0, at the maximum position velocity is 0 and acceleration is max. Okay, at the mean position velocity is maximum but acceleration is 0. Okay, because it is not accelerating, if you stop the velocity it will stop. Okay, acceleration is 0, that's why it is called mean position. So velocity is maximum and acceleration is 0. So option B is correct. Now next question. the ratio of kinetic energy to the potential energy of a particle executing SHM at a distance equal to half its amplitude, the distance being measured from the position of equilibrium. Okay, so the ratio of kinetic energy to the potential energy of a particle executing SHM at a distance equal to half its amplitude means the distance is equals to a by 2. Okay, so what is the velocity? The kinetic energy in SHM is given by half m omega square a square minus x square. Okay, and potential energy is given by half m omega square x square. Okay, so if you add them, you get half m omega square a square, right? So now what you have to find? You have to find the ratio of kinetic to potential energy. So ratio of kinetic to potential is basically Ek by Ep you are trying to find. So if you see that this part is common, so they will cancel. You get a square minus x square divided by x square. Okay, now what is x? X is a by 2, so a square minus a square by 4 divided by a square by 4. Okay, a by 2 whole square is a square by 4, so you get 3a square by 4 by a square by 4. So this 4 cancels, a square cancels, you get 3:1. So answer will be 3:1. Option B. Next question. A pendulum oscillates simple harmonically if and only if the size of the bob of the pendulum is negligible in comparison to length of the pendulum. Yes, this is a correct statement. The angular amplitude is less than 10 degrees. This is also correct because we do one simplification saying that sine theta is nearly equals to theta. For that is only possible when the angle is less than 10 degrees. So both 1 and 2 are correct. Both 1 and 2 are correct. Now next question, the displacement of particle, this is a 2021 question. Displacement of a particle executing SHM is given x equals to 3 sine 2 pi t plus pi by 4, where x is in meters and t is in seconds. Okay, the amplitude and the maximum speed of the particle is, so amplitude is definitely 3. Okay, so amplitude is 3, and what is the maximum speed? Maximum speed is basically omega into a. So what is omega for here? Omega is 2 pi, so 2 pi into amplitude, that is 3, that is 6 pi. Okay, 6 pi is the maximum speed, so 3 meter 6 pi meter per second square. Maximum speed they have asked, not acceleration, so it will be this. Okay, in case of acceleration is omega square a. So the tray mass of the tray is 12 kg, supported by 2 identical springs as shown in the figure. When the tray is pressed down slightly and it is released, it executes SHM with a time period of 1.5 seconds. Okay, so here we have our, say this has a spring constant K, this one also has a spring constant K, then the total spring constant of the system is 2K. Okay, so you have to find the spring constant for each spring. Now what is the time period of oscillation when it is oscillating in a spring? So time period of oscillation is 2 pi square root of m by k. Okay, so time period, this t is 1.5, 2 is obviously 2, and pi is 3.14. I am assuming 3 for now for simplicity. It answer whatever we will get will be slightly more than whatever we are getting. 3.14 we have approximated so that the calculation becomes easier. Now do the square on both sides. We get 1 square equals to 4 square into m by k. Okay, sorry, m by 2k. Okay, here we have spring constant 2. So what is the value of k? So k equals to 4 square, that is 16, into m is 12 divided by 2. So 6 9s are 96. It is very close to 96, but more than 96, only one answer which is more than 96, that is 105. Even though the answer is not super close to our assumed value, because we have done a approximation over here, 3.14 was there, so that value plus we have done the square of that entire term, so that's why our answer is 96. Okay, don't be afraid. Only thing you have to understand that you have to find the closest answer. A piston is performing SHM in the vertical direction with a frequency of 0.5 Hz. A block of 10 kg is placed on the piston. The maximum amplitude of the system such that the block remains in constant with the piston is. So let's understand the question. So piston is performing simple harmonic motion with the frequency of 5 Hz. Okay, 5 Hz, 0.5 Hz. That means it's oscillating 0.5 per second. Okay, 10 kg is placed. You have placed a mass of 10 kg on top of the piston. Okay, the maximum amplitude of the system such that the block remain in contact with the piston. So what should be the amplitude of the piston such that this block will remain in contact with the system? That means when this is going down, okay, when the piston is going down, down motion should not displace the piston. Okay, so if you are putting something on a vibrating thing, generally it either goes off or goes down, but if you adjust the amplitude, then you can find whatever is the correct value where it will not move. Okay, so basically we say that the gravitational acceleration should be equals to the acceleration of the system. Okay, so gravitational acceleration should be equals to the acceleration of the system. So what is the formula for acceleration? Acceleration is omega square into a. Okay, and that should be equals to gravitational constant. I am assuming that value, gravitational constant value, is g is equal to 10. Now what is omega? Okay, omega equals to 2 pi into frequency, right? Omega equals to 2 pi into frequency. So omega square will be equals to 2 into 3.14 into 0.5 into amplitude A equals to 10. And there is a square. So 2 into 0.5 is 1. So we are getting this as 9 point something square. I think 9.2 into A equals to 10. Okay, so A will be equals to, if you consider this 9.8, I think it will be better now. Okay, because all the answers are very close. So the answer will be 9.8 by 9.2. Okay, so which is basically close to 1, but slightly more than 1, but not exactly 1.5. 1.5 means it would have been 13.5. If it was 13.5, then it would have been 1.5, but because we have approximated this 3.1 value, it will be approximately close to 1 meter. Okay, so if the amplitude is close to 1 meter, then it will not, the object will not go out. Okay, so this is the answer. Next question. Two simple pendulums A and B are made to oscillate simultaneously, and it is found that A completes 10 oscillations in 20 seconds and B completes 8 oscillations in 10 seconds. The ratio of lengths of A and B are. So we know that T is equal to square root of L by G. Okay, 1 by 2 pi. Basically the meaning of that is time period is proportional to square root of L. Okay, proportional to square root of L. Okay, higher the length, more will be the time period, right? So first wire does a oscillation of 10 oscillation in 20 seconds. So what is the time period? So T1 in 20 seconds 10 oscillations, so one oscillation will be in 2 seconds. Okay, so 20 by 2. And for T2 it will be 10 by 8. Okay, 10 seconds for 8 oscillations, so time period is 10 by 8. Okay, it will be 5 by 4. Now the ratio of the lengths. We are trying to find L1 by L2. So what we have to do? You have to do T1 square by T2 square equals to L1 square by L2 square. Okay, we have to what I am doing, L1 by L2, because they are proportional to square root. We just have to do the squares on both sides. So you get T1 square is 4, T2 square is 25 by 16, and that is equals to L1 by L2. So L1 by L2 equals to 4 into 16, that is 64 divided by 25. So L1 by L2 is 64 by 25. Next question. A parallel particle executing SHM has maximum speed of 0.5 meter per second and maximum acceleration of 1 meter per second. The angular frequency of the oscillation is. So we know that maximum speed is given by omega A, whereas maximum acceleration is given by omega square A. So we have to find the angular frequency, that is omega. So what we have to do? We have to, omega is basically A by maximum speed, right? If you divide this number with this number, you get the angular frequency. So acceleration is given by 1 and velocity maximum is given by 0.5, so it will be 2. So omega is 2 radian per second, not 2 pi. Don't get confused, not 2 pi, it is only 2. Okay, the speed of sound in an ideal gas at given temperature T is V. The RMS speed of the gas molecules at the same temperature is Vrms. The ratio of velocities of V and Vrms. So first of all, we have to find what is the V. V is given by square root of gamma RT by M. Okay, and Vrms for any gas is given by square root of 3 RT by M. This comes from Newton's and Laplace correction, and this is from Vrms expression. You can convert that value to RT by M. I have done this in my class. If you have missed that, you can go and check that out. Now the ratio of V by Vrms is basically gamma by 3, square root of gamma by 3. Now that value for helium and oxygen gases are X and X dash. So for helium this value is X, okay, for helium, and the same value is X dash for oxygen. Okay, so basically they have different gammas. So what is the ratio of X by X dash? X by X dash is basically, that means X is proportional to gamma, 3 is constant, so X by X dash is gamma of helium divided by gamma of oxygen. Okay, so what is the gamma of helium? Gamma of helium is 1.67 divided by 1.4. Now because they have given in this form, you have to find the gamma in the old format, that is 2 by F, that is 1 plus 2/3 for helium. Helium is monoatomic gas, right? So it will be 5 by 3, and this is for helium, gamma helium, and gamma oxygen is 1 plus 2 by 5. Gamma oxygen is 1 plus 2 by 5, that is equals to 7 by 5. Okay, now you have to put that value over here. So it will be square root of 5 by 3 divided by 7 by 5. So it will be 25 by 21. So 25 by 21, so 25 by 21 square root, so that is 5 by square root of 21. So correct answer option A. Next, to propagate both longitudinal and transverse waves, a material must have bulk modulus and shear moduli. Okay, bulk modulus is for longitudinal wave and shear moduli is for transverse wave. Okay, so both bulk and shear moduli must be have. The equation of stationary wave is 2 sin pi x by 15 cos 48 pi t. The distance between a node and its next antinode is. So we have to find the node and next antinode. That means we have to find the distance between lambda by 4 is our answer. Okay, so we have to calculate what is the lambda, right? So here sine is basically we know that what is the normal form for standing wave. It is basically amplitude sine kx cos omega t. Okay, so what is k here? K is pi by 15. So k is pi by 15. Now we know that wavelength is given by k is equal to 2 pi by lambda. So this is the formula. So that is equals to pi by 15. So from here we get lambda is equal to 30. Now node and antinode is basically lambda by 4, as I said. So lambda by 4 is equals to 30 divided by 4. So 15 by 2, 7.5 units. So answer is 7.5 units. Next question. A metallic wire of 1 meter length has a mass of 10 into 10 to the power of minus 3 kilograms. If a tension of 100 Newton is applied to a wire, what is the speed of transverse wave? So speed of transverse wave is basically given by tension divided by mu. Okay, tension divided by mu. Now what is the mu of the wire? Mu is mass per unit length. So mass is 10 into 10 to the power of minus 3, that is 10 to the power of minus 2. Okay, this is immaterial and length is 1 meter. So it will be 10 to the power of minus 2 is the mass per unit length. So what is the tension? Tension is 100 Newton and mass per unit length is 10 to the power of minus 2. So you get 100 into 100. Right, square root of that, so you will get velocity is 100 meter per second. Okay, so 100 meter per second is the answer for this question. Next question. The waves set up in a closed pipe are longitudinal and stationary. Okay, wave set up in a closed pipe are longitudinal and stationary. They are not transverse. If it is a string, it will be a transverse. When two tuning forks A and B are sounded together, 4 beats per second are heard. Okay, the frequency of fork B is 384 Hz. When one of the prongs of the fork A is filled with and sounded with B, the beat frequency increases. Then the frequency of the fork A is. So very interesting question. So first of all, the frequency of B is 384. So what are all the possible frequency of A? So there are two possible frequencies. 384 minus 4, that is 380 Hz, or 384 plus 4, 388 Hz. So both of these two frequencies will give 4 beats per second for 384 Hz. Now if you add some mass to it, that is you have added you have filled the fork with some wax. Okay, in that case what happens is that the frequency generally increases. Okay, frequency increases. So in this case, if the frequency increases, so suppose for example 380 becomes 381, so in that case the beat frequency increases or decreases. So if this frequency increasing, then the beat frequency is decreasing, right? But in this case, if you add the mass, it will become 389. So in that case the beat frequency is now 5. So here in the question it says that as you add the mass, that is as you fill it, the beat frequency increases. So if the beat frequency increases means the correct answer will be 388 Hz. Okay, so 388 Hz is the answer for this question. I hope you liked today's session. It was little long, but it was very effective. And if you have many more doubts, please don't forget to ask in the comments below. I will try to answer as much as possible. I will be back with more videos. Till then, bye.